I've been turning my home into a smart home, one upgrade at a time. This thermostat was the next thing that had to go. I got a smart doorknob, smart locks, smart TVs, but every time I walk past the thermostat, this thing reminded me that it was still living in the past. So today we're finally going to fix that. I'm upgrading this old thermostat to a smart thermostat, and I'm going to show you exactly how I installed it. But we're living in 2026. I'm going to be using ChatGPT to help me install this thermostat. First, start off by taking a picture of your existing wiring, but also take note of how the wires are wired, because that's going to help you wire it on your new thermostat. And you'll want to label them with the appropriate labels. As you can see here, the green wire is labeled with the G sticker, and the rest of the wires are labeled according to the old configurations. Next, you'll have to remove the screws that hold the base plate to the wall. Then you'll have to carefully take the base plate off, trying not to get the wires behind the wall. So I use these vice grips to temporarily hold the wires until I can get the new plate on. Before we get to rewiring everything back together, now will be a good time to get familiar with the wiring, since you'll be installing your thermostats from here on out. Here in this picture, you see some Klein's multimeter. Klein is just the brand, but this multimeter is for testing voltage to see how much current is going through each wire. Here's a diagram I was able to pull up from ChatGPT showing each color-coded wire, the name of each one, and what its function is. The red wire represents power. It supplies 24 volts from the Hvac transformer to the thermostat. It powers the thermostat and allows it to send a signal to the heating and cooling equipment. Next, we have the white wire. The white wire typically controls the heating system. When the thermostat calls for heat, it sends 24 volts through the white wire to activate the furnace and heat source. So we have the red for power, white for heat. Now we have the yellow that's going to represent the cooling system. This is going to send a call from your thermostat to the outdoor compressor or AC system. With the red wire giving power to your thermostat, the white wire is calling for heating, the yellow wire is calling for cooling, the green wire is going to be for your blower. This blower is located on the inside of your furnace, and this is where all of the forced air goes, coming through your vents and all of your ductwork. These last two wires have two separate important functions. The blue wire is typically the common side of the 24-volt transformer circuit. It provides the returning path for 24 volts back to the HVAC control board. This wire powers smart and digital thermostat continuously. It completes the 24-volt circuit, usually connects to the C terminal at the thermostat and HVAC control board. It does not normally turn on heating or cooling components by itself. The last wire on the standard thermostat, the orange wire, is commonly used for a heat pump system to control the reversing valve. The reversing valve changes the direction of refrigerant flow, allowing the heat pump to switch between cooling and heating. You will use this wire only if your condenser has a heat pump built into it. So how does a heat pump function? Was a question that I have. Here's a video that ChatGPT sent to me.
A heat pump is an air conditioner that has one added component that allows it to function as a heater as well. Let's first talk about how air conditioning works, because that will set the tempo for understanding how a heat pump works. Now, you might think that your air conditioner is simply blowing cold air inside your home, but that's not what's happening. What's actually happening is that your air conditioner is circulating refrigerant through a coil that is inside your home and a condenser that is outside your home. And this process is actually transferring heat from inside your home to outside your home, which is why you get nice cold air coming out of your vents, and which is also why the air coming off the top of your condenser is extremely warm. And if you've never been outside by your air conditioner when it's running and felt the heat coming off of it, when you're finished watching this video, go check it out and you can see for yourself. And the heat coming off of your air conditioner is actually the heat from inside your home being transferred outside through the refrigerant lines. Right now, we're going to go look inside the inner workings of a heat pump and point out what allows an air conditioner to be transformed into a heat pump. And that one component is what's called a reversing valve. So right now I have a Daikin DZ5 Series 2 pulled apart, and I'm going to show you what a reversing valve looks like and what it does. So this little device right here is the reversing valve, and that little device is the only difference between an air conditioner and a furnace, with the exception exception of a defrost control board and a few other control logic and wiring items, but mechanically speaking, this is the major difference. And what this component does is it reverses the flow of refrigerant so that instead of transferring heat from inside the home to outside, it transfers heat from outside the home to inside the home. And in a nutshell, that is what defines a heat pump and makes it different from a traditional air conditioner.
Now that I got my wires assembled, I'm putting the face of the thermostat on, waiting for everything to get powered up. Once I confirmed I had power and did all my configurations, I went to the vent to make sure that everything was working and outside unit had kicked on. It did take a couple minutes before the thermostat configured, but as you see, the unit is working. Thank you for watching this upgrade on this thermostat. Be sure to check out the channel for more DIY videos, and I'll see you in the next one.